Welcome back to the third and final video in this series of integration by substitution videos. I'm going to jump straight into this question here. So in this process, I'm going to let u equal x plus 1. That means that du dx equals 1, which means that du equals dx. The other thing I'm going to notice here is that if I rearrange this u equals x plus 1, it gives x equals u minus 1. So I'm going to make the substitutions back into my integral. So that's going to be u minus 1 in the numerator divided by the square root of u du. The other thing that I have to pay attention to here, because we're dealing with a definite integral, I have to pay attention to the terminals. Now, these terminals, they were originally telling us two x values between which we should evaluate the definite integral. The problem here is that we no longer have an equation in terms of x, we have an equation in terms of u. So I need to figure out what those terminals should be in terms of u, and I'm going to use this equation right here. So when x equals 15, that's the upper terminal, that should give u equals 16. So I can replace the 15 with a 16. And also, when x equals 0, the lower terminal, that's going to give u equals 1. So that will be my new lower terminal. It's really important to remember to do this step in this process, again, because we have changed the variables in the question. So now I should be good to evaluate this. I'm just going to firstly write this just by dividing each of the values or each of the terms in the numerator by the denominator. I should get u to the power of half minus u to the power of negative half. There's still du there. So now I need to anti-differentiate this. And so that's going to give, now u to the half becomes u to the 3 on 2 divided by 3 on 2, which should give 2/3 u to the 3 on 2 minus, and u to the negative half becomes u to the positive half divided by positive half, which means it becomes 2u to the positive half. And that's between 1 and 16. To make this a little bit easier to evaluate, I'm going to write this as 2/3 of the square root of u cubed minus 2 times the square root of u between 1 and 16. Now, doing the definite integral, I now substitute the upper terminal in first. And so that's going to give me 2/3 of the square root of 16 cubed minus 2 times the square root of 16. And then I subtract and I substitute the lower terminal in to get 2/3 of the square root of 1 cubed. Don't know why I put brackets around that. But anyway, minus 2 times the square root of 1. And I don't really know what 16 cubed is, but I do know that the square root of 16 is just 4, and that 4 cubed is 64. So this is 2/3 of 64 minus, now that just becomes 8, and then minus 2/3 take away 2. To make this a little bit easier to evaluate, 2/3 of 64 isn't very nice, so I'm going to write it as 128 on 3. I'm then going to subtract the 2/3 because they have a common denominator. I'm also going to have a minus 8 and a plus 2 when I expand that all out. And so finally, I've got 126 on 3, which works out to be 42, minus 8 and then plus 2, which gives me the answer of 36. So this all worked out very nicely. Just really need to highlight this step here. It is very important to do that, changing the terminals. However, you could alternatively work through it without changing the terminals, and just once you get to this line here where you have anti-differentiated it, substitute the u back for x plus 1, and then use your original terminals. I just think it's nicer to do the changing terminals. It's not a difficult process, and I think it really makes sense in terms of the whole problem. So yeah, that would be my recommendation. But anyway, it's up to you to decide which method you choose to use. So I'll leave that there and see you next time.